Well, good evening, and I am here to give you a little taster tour of all the different aspects of deep sea mining that may lead us to have, after a couple of false dawns, perhaps a current dawn which might lead to the full time of day. Now, in order to be able to do this, as you will realize, there are a lot of different challenges that the resource is going to have to meet. And the resource I'm going to focus on here is the very first one that gained international attention, and these are the ferromanganese nodules. Now, there are two other major deep sea mineral resources that I'm not going to address in this talk. One of the polymetallic sulfides, which we didn't even know existed until the late 70s, and the other are the ferromanganese crusts, which we have known about as long as the nodules, but they're so much harder to exploit because of the way that they form that I'm not going to talk about either of those. I'm going to talk about the nodules because they have received the most attention, and they are also still likely to be the one that will be most rapidly exploited if this dawn becomes a full sunlit opportunity for the deep sea industry. Now, here we have the resource. That is about what they look like, and I brought some with me to show you, which I thought I had in here. The nodules are very, very crumbly. So be careful, those of you who don't want to get your nice shirts. And I counted them, I want them all back. Alright, here we go. And the reason we're interested in them, this is quite a complex slide, and the takeaway message here is that they are full of interesting metals that we need more and more for all our various tech equipments, all our underwater materials, our aircraft. They have lots of strategic implications and uses. They are not renewable. They grow extremely slowly, and it is estimated that just in the major area that is of most prospective interest, which is the Clarion Clipperton Zone in the North Pacific, that we have enough to keep us going for some little time at even projected increased demand, 2,100 million dry tons. They are commercially attractive at approximately 10 kilograms per square meter. So this is a very, very useful resource. This is a typical field. They're basically potato shaped, as you can see, those of you that are going around. This is, however, deceptive in the sense that the nodules aren't always this abundant. They can vary over very, very small distances from no nodules at all to an abundance like this. And that is part of the problem with assessing them as a resource, because this variability in terms of coverage on the ocean floor is quite extensive. Also, the variability in metal content is not as predictable as it might be. The nodules, when you see them in a box score, this is from the French license area in the Clarion Clipperton Zone in the North Pacific, you see that they are embedded in a sediment, just like this. And this makes, in fact, them quite easy to exploit technically, because all you really need to do to boil it down to first principles is hoover them up, these potatoes, out of this sediment. Now here's the Clarion Clipperton Fracture Zone, which is where the most prospective resource for these nodules is. There are nodules in the Atlantic and in the Central Indian Ocean Pacific Basin, but this is the best resource, and this is where most of the attention and the study has been going on for the last 50 years, if not more. They were in fact first discovered by the HMS Challenger. When the HMS Challenger did its pioneering, the UK was the first to do this, pioneering research crews all the way around the world, took 5 years, and they're still analyzing the data, by the way, but several of those nodules that they dredged up from their dredging all around the world, and the ones from the Pacific are in the database for my thesis. So even back then, the chemistry was good enough. They could use those types of analyses to use today in our contemporary research. Now, this is not a new industry in one sense. The early industrial interest, as you can see, went through the entire world in terms of the types of companies that it attracted and also the nationalities that it attracted. This Archimedes screw type collector, by the way, is still in use, and it is being developed further by Lockheed in the current iteration of the deep sea, of the nodule mining industry to develop for commercial exploitation. There is, of course, the best spy story still in the world attached to nodule mining, when it was a nodule mining vessel was disguised to help the U.S. recover a submarine, a Russian submarine, in the part of the Pacific that also happened to have nodules. So this is a totally great story that you need to familiarize yourself with if you don't know it already. So the actual technology of getting them up already has a certain vintage as well. There was pilot mining done off the state of Hawaii already. 800 nodules were brought up, and the other consortia also managed to bring up some nodules. And then this was the end of the first false dawn. Everything went major pear-shaped in terms of both the commercial situation and the legal situation. At the this started to go seriously wrong in the early 1980s. Now, in terms of mining, and I'll get into this a little bit further towards the end of my talk. Now, in terms of mining, the actual mining cycle for nodules, because it's essentially a hoovering mechanism, is quite simple conceptually. You're looking at, first you explore to find out where they are and what the metal content is. Then there's the exploitation phase, which is the mining and the processing. I will not be talking about the processing because most of that will still, so far, go out on land. The only bit of processing that's going to be done at sea is the dewatering of the nodules once it comes up to the surface vessel. And then there is the closure of the mine. The site remediation and the monitoring of the site after the closure of the mine is now a major consideration that you must all keep in mind. This didn't used to be a major consideration, but it is now because of the regulatory constraints that are being placed on the mining operations internationally. And the mining concept as such is also quite simple. You have a seafloor mining tool, which is essentially a collector. You have a vertical transport system, getting it up from the bottom to the vessel. And we're talking serious distances here, between 3,500 and 4,500 meters that you have to get these nodules from the seafloor up to the vessel. And then we have the mining support vessel. And then, as I said, a little bit of vessel-based ore preparation, dewatering and dealing with the fines, the remains of the dewatering. Now, what is really interesting about marine mining is that it is one of the most interdisciplinary of all the industries you can find. It's particularly good for a society such as this one to think about, particularly when they also have a major, I'm a member, by the way, of the SUT as well, a major student outreach program. You can fit just about any job you would want into a marine mining context. I mean, I straddle the interface between the law and marine science, but as you can see, you can be an engineer, you can be a naval architect, you can do just about any job in a marine mining context that you would like. And this makes it possible to attract a wide number of people to this particular industry. However, even though a lot of the inspiration is drawn from existing industries such as the oil and gas, the dredgers, and the wet mine and the wet diamonds people, the ones like the De Beers off Namibia, and then all the cable folks, creative adaptation is where the fun comes in. And this gives you an idea of what we're looking at in terms of inspiration, in terms of two of the major industries, the dredgers and the offshore oil and gas. And here we have what an offshore nodule harvesting system looks like. You'll notice that there's two collectors. You want to bear that in mind as well. Everything I know, what the industry is willing to tell me, is that they're all looking at a two collector system rather than a one collector system. But not necessarily off one ship as far as I understand it, but that is still to be decided. I'm going to give you a quick overview of what it looks like from an actual nodule harvest vessel standpoint as a blow up. These are the four areas that you can see. The surface vessel needs to be purpose designed. And as far as I know, there isn't one on the market yet that is being developed. This vertical lift system, the technology for that is being developed, and we'll look at that in a bit more detail later. And then we have the seabed collector. And I'm going to start with the vessel and work my way down, because most of the current action is at the seabed collector level, technologically speaking, right now. So the blue nodule deep sea mining concept picture here gives you a slightly more complex idea of all the processes that need to go on in addition to the four major areas that I have outlined. The blue mining project, you should also know, is a major EU funding project, and the EU is quite heavily involved in funding various research projects and technological development projects in the nodule mining sector. So, with regard to the surface vessel, you can already see all the various elements that need to be included, which will require something completely purpose-built, and it also has to accommodate, which you don't see here, barges that come alongside very, very regularly to offload all the nodules and take them back to shore. The idea is that this vessel stays offshore for a very, very long period of time. You remember that Clarion Clipperton Zone picture I showed you? You've got at least 3 or 4 days steaming to the first seriously interesting mine site there. And you can't be coming in and out all of the time with your vessel and your collector. So the idea is that the barges come and do the route, including the transfer of crews on and off as well, and the vessel stays out there for as long as it possibly can. Some of the figures that I've seen are looking at operational days of 250 out of a 365-day year, for example. And I've heard some contractors tell me that they'd really like that ship to stay out there literally for years on end and everything shuttling back and forth. What that also requires, when you think about the technology in terms of maintaining the technology in a functional way on the seabed at those temperatures and pressures and for such a length of time. Also, they've got hurricane seasons there, right? What all of this entails, some really, really interesting creative adaptation challenges that the industry is going to have to meet in order to be able to operate profitably. So the vertical transport system I have alluded to. There are all sorts of various ways that they need to deal with it, that they're trying to work with. The problems include just, the consistency of the slurry that comes up. That is not at all clear how they're going to deal with that on the sea floor. How it's going to change its consistency as it comes up. So clogging is going to be a major problem. Cold is going to be a major problem. We're looking at 4 degrees C down there, and then it's going to warm up as it comes up the tube. What is going to happen there? When I gave one of these talks at the University of Hawaii a couple of years ago, one of the original Lockheed guys, who was doing something completely different now, but he'd been on one of the original Lockheed cruises, in fact also on the Glomar one, he came and he had kept for 50 years, he had kept a bucket of slurry right? And he came and showed it to me. And he said, this is what clogged up our system, and we're still trying to analyze what happened for 50 years. And I have to say, this is something that I found totally enchanting about this sector, is that everybody who's still alive, who was involved in deep sea mining in the 70s and had to go do other things, deeply regrets that false dawn, right? Because it was the most fun they had ever since. Doing that, and they're all really regretting that they're too old to still go to sea, but we get huge interest in this. It's captured the imagination and kept it of some really super people over nearly half a century. So here are the challenges. I think I've given you most of them already as I was speaking in the vertical transport system. And you know, you've got corrosion to worry about. You also have to remember that this is going to move constantly with the ship as well as the collector moves, so you have that to worry about. And that is a ballpark operating depth. There are certain areas of the CCZ where the resource is actually 5,500 meters, so it's even deeper than what's being shown here. Now, the collectors. This is where the major attention is being given still now. There are various types, but they seem to be boiling down to either the Archimedes screw, which as far as I know, Lockheed is the only one of the current nodule contractors that is still proceeding with that. Most of the others are looking at a track wheel type system. There was a really interesting period with the Japanese who had a towed bucket system with lines, yes, and it got hopelessly tangled up. And I believe they've abandoned it, but so that's why this is not part of the current mix. But the Japanese, when they got it untangled, it actually worked quite well. But the tangling issue was such that it became insuperable. So now with nodules, this is basically what we have now on the various options. Seabed bathymetry is one that you really need to worry about, in the sense that the nodules are in what is known as the abyssal plains. But abyssal plains, there's not what you think of as plains, which are flat. My country, the Netherlands, that's flat. The abyssal plains, they're not flat. You have undulations, which can go up to 1,000 meters even, yes? And even where the hills are much lower, they're still quite steep. So the key is to design your collector to maximize as much as possible, of course, the angle at which you can still collect without tipping over. And that is a subject of considerable research. Right now, they're all being controlled from the vessel by various power umbilicals, but they are looking at trying to make them a lot more autonomous, which is, again, an element of great importance, because that power umbilical over 4,500 to 5,000 meters, that's a big problem to keep that going in any kind of a reliable way. Then a major issue with the collector is all the sediment that it's going to kick up. What you don't want is having too much sediment go up your pipe to the ship. You're after nodules, you're not after sediment. You also don't want a great deal of sediment clouding around your collector, because that has severe environmental impacts on the associated biota. You also have to be careful as to how heavy your collector is, because if you compact the seafloor too much as you go over it, you also then have a problem with the regeneration of the biota, which are used to a different consistency. You also have to worry about what happens with the slurry as it goes up. You want to make sure that you don't release sediment through the vertical transport system into the water column on the way up. So all of this requires a great deal of creative design. Now, with the collector, the Patania is being introduced here. As you can see, it's a caterpillar type tracking system, which was tested successfully for the first time in 4,500 meters of water in 2017, and it is done in order to develop the basic structures that are needed for a fully fledged collector system, which is going to operate on tracks. Here it is before it was put on the seafloor back in 2017, and it worked extremely well. And I was on that cruise in 2017, and this is the spinach part of the lecture, folks. At the end of the lecture, there will be a 12-minute video of that cruise, which I hope will give you an idea of the, that will be your dessert that you can look forward to, give you an idea of what's involved in a deep sea mining research cruise in terms of resource assessment, in terms of technology development, and in terms of environmental baseline data gathering. Because all the deep sea mining cruises that are going on right now in the CCZ address those three elements. So in this particular cruise, from the technology development side, we were looking at the Britannia. Now, Britannia 2, this was going to go to sea in the spring of this past year, 2019. I was also on that cruise. And as you can see, it's 4 times bigger than Britannia 1. It's about half the size of what a full-size collector will be. And it is, as you can see, with very many more bells and whistles than the little Britannia. Unfortunately, it had there was a technical issue which had nothing to do with the collector, but did make it possible to do the full testing in the first quarter of 2019. So we're hoping to be able to get back in this coming year to deploy it again in full mode in the Clarion Clipperton zone and do exactly the same type of work that I just said that I'm going to show you in the movie at the end of 2017, the environmental data collection, technology development. And we're also going to do some experimental work, which we're hoping to be able to do with another vessel out of usually, we hope that we get the Zolla, which is based in Germany. It's the German research vessel. And this is in the context of another EU mining research project, which is Mining Impact 2. And then, if everything goes well, DEME is going to build a serious suction robot, which will not only collect, but also it will be attached to a vertical transport system, and they will then test the whole business all the way up to the surface vessel. Now, there's some serious investment going on right now, as you can see, and the first commercial nodule mining might take place, and this is why I'm not saying we don't have another false dawn yet in 2027, but there are other constraints which are not technical, which may yet have an influence on this, to push that date a little bit further into the 30s, but we'll come to that in just a second. Now, there are lots of environmental issues involved with deep sea mining, and the blue ones are the most difficult ones to deal with. In my view, the sedimentation one, in fact, is the least difficult because it can be designed out for. What is really difficult is the top one. What you need to know is that there are 2 types of organisms in the deep sea, and that are associated with the bottom, and there are the organisms that like to attach themselves to hard surfaces and the organisms that like to live in or on soft surfaces, and the 2 are mutually exclusive. So if you're removing nodules, that's a hard surface. Everything that likes to live on nodules has nowhere to go if there are no nodules or other hard surfaces there. One of the subjects of the experimentation is to see whether any kind of hard substrate can just be replaced, so that does it have to be hard, is that all? Or does it actually have to be of the same geochemical composition of the nodules. Now you are looking at the only person on the planet who's actually done this research. This is back in the 80s, during the the second false dawn, when there was still funding for this sort of thing, where I actually put some experiments down on a seamount to see whether there was differential settlement between the surface of, I was looking at across with the principles the same, nodules or any generic hard substance. And the trouble is that some organisms, yes, other organisms, no. And then the ones that didn't settle at all, we don't know whether they just didn't happen to be there at that time, or whether we brought the experiments up too early. Because another problem with doing all these experiments in the deep sea in terms of regeneration is that everything takes much, much longer in the deep sea. All the processes are much, much slower. I was doing this for my master's back in the 80s, and to get any kind of serious data, these experiments would have had to stay down for 15 or 20 years, and my thesis chair said he wanted me to have my master's before he died. So we brought them up after 18 months, which was enough to give us a vague idea, but not nearly enough. So you see what we're confronted with here. If we're trying to actually do evidence-based regeneration experiments and translate that into regulatory requirements for the companies that are going to need to deal with closure. Remember, remediation. It's not a trivial exercise. And so here we are, the slow and different regeneration, because that's the other problem. I was looking at communities that had been there a long time, and we don't know whether we have a whole series of intermediate communities first. So there are environmental issues. This gives you a summary of the environmental issues from the support vessel all the way down to the sea floor. This happens to be from a sulfide system, but basically all the impacts are exactly the same. So you're looking at the lights, the noise, the discharges, the traffic back and forth, which is not on this, from the bulk carriers. Well, yeah, they actually have it, so that's all right. And then you have all the issues down at the bottom as well. So it's quite a large panoply of environmental considerations, most of which can be designed around if the companies are willing to spend the money to deal with it from a technological aspect. And the regulatory system is driving them in that direction. This is an example of what we have here, very, very striking. Remember I said that if the nodules are gone, nothing's going to come back? Well, that's what you have. And so everyone who's used to having a little potato to come and find their home on has nowhere to go. So one thing that I'm suggesting to the contractors that will listen to me is that they design their collector, that as they hoover up nodules in front, they leave some nodules behind, that they don't hoover up everything. Or not as an alternative, but in addition, that they maybe don't strip, that they leave strips in between of undisturbed nodule areas. Sedimentation is a bit of an issue there, but that can be dealt with. But what we don't want is, complete cleaning of the ocean floor like this. Now there are advantages. Remember, we're looking at comparisons with land-based mining as well, because you will see if you go into the deep sea mining versus land-based mining dialogue that a lot of groups are saying, yes, well, but what about land-based mining? Well, here are the advantages of deep sea mining over land-based mining. First of all, you don't have any overburden to remove, all right? You can get at least 3 metals from the same site, and you can move your infrastructure. You're not having to run roads through rainforests. You have no human populations, at least locally, at least as far as we know. We haven't found any down there yet. We don't have any fresh water issues. There are considerable advantages, all of which are not possessed by the land-based mining groups. Now, I'm not making any comparisons here. It's just that all of this needs to be weighed up when you are trying as a society to decide whether you want to go into the deep sea for these metals. Now, this is the problem with the 2027 mining date, and it is regulatory. Now, this is a very complex slide, and the takeaway message basically from it is that all of these nodules are in international waters, which means 168 countries have their say in how they get exploited, all right? And that's like herding cats. Anyone who follows the UN, where there's 192 countries and the difficulties that it has, that gets everything done, it's not made any easier when there's only 168 countries, all right? It's run by a treaty. The head office is in, of the agency that's in charge of all of this is in Jamaica. Exploitation regulations are currently being drafted, and it's in those regulations with all the environmental requirements that those regulations are proceeding to set out in some considerable detail that will have tremendous commercial and economic ramifications for the contractors that are trying to decide how much all of this is going to cost for them to put in place. And they are being, they're in their second iteration now. You can see the very bottom, incorporating environmental requirements, also for exploration, but just worry about the exploitation right now. The regulations I will come back to in just a second. What we have here in the Clarion Clipperton Zone are a very large number of countries that are already out there, each have a different license area. That agency that I spoke to you about, it is in charge of granting permission to mine out there. And you can't go out there if you don't have a license from that agency in order to work. Now, for years, there was very, very little interest in deep sea mining. This was the great dry period of 25 years when nothing really happened. There were some countries out there just leisurely looking around with a license, but about 6 years ago the private sector got involved. And that is what has started this new dawn, which may end up in a full sunlit day for deep sea mining. It may. It's not entirely sure. The private companies are the ones in the top 5 there. They're all the UK has one, by the way. And why is it a Lockheed subsidiary? Because the United States is not a party to the treaty. So the United States has no right to go out there and explore, let alone exploit. So Lockheed, who, as you recall, had considerable interest and experience already out there in the 70s, it got into bed with the UK, and we have a wholly owned subsidiary here now, and the UK is the sponsoring state for UK seabed resources here in Britain. Now, I point out that Singapore is Ocean Minerals Singapore. It's not entirely clear how private it is, because a major investor in Ocean Minerals Singapore is Temasek, which is the sovereign wealth authority, but we're considering them private for our purposes. So we've got 5 private companies who have to report to shareholders. All the others are either states in their own right or state-owned, and their responsibilities and obligations, both commercially and politically, are quite different. This is what the CCZ, remember that CCZ I showed you on the first, on the first couple of slides? This is the licensing situation with those 18 countries. The one country that has the most licenses over the largest extent of it is China. And now this is particularly interesting because China is also a land-based producer of metals, and China is buying up other land-based producers throughout the world. Chile is one of them, major copper industry. The Congo is another major cobalt industry. So how China is going to position itself as both a land-based producer and a deep-sea mining country is going to be really, really interesting. Just to give you an idea of what this looks like in terms of the environmental effects of all of this, and the reason this is particularly important is that one of the areas that the Seabed Authority based in Jamaica is required to look at is the cumulative impacts of all of this mining. And it's not at all clear what that really means and how you are going to define your relevant area for determining these cumulative impacts. Essentially, the idea presented here is that you have a very, very small area that is in fact going to be affected by deep sea mining for the first 30 years at least of a mining license. And it looks like the economics is only going to support one, maybe two mining industries at most for the first 30 years. So this is a very, very small area. So if you're looking at cumulative impacts, if you're a regulator, how wide do you make this area of attention that a miner will have to worry about as it designs its mining system and after the mining system closes? And I keep harping on this closure aspect because the economics means that you're no longer getting nodules out, but you're still having to pay to go look at it, right? So your resource is no longer funding what you're needing to do after the mine is closed. So anyway, after 30 years, a nodule operation will have disturbed the comparative table area the size of a mobile phone, right? And you have to confront, sympathize with the regulator on the issues, just what cumulative impact actually means in this context. Now, you remember I remarked to you on the draft exploitation regulations. What you also need to know is that the treaty that runs all of this has identified all of these mineral resources in areas beyond national jurisdiction as the common heritage of mankind. We don't know exactly what that means, but because it's not been judicially interpreted, but what the International Seabed Authority has decided is that it means that the entire body of mankind or humankind has to be consulted on the exploitation. So what does it do? A unique in the UN family of agencies, it is consulting mankind on the exploitation regulations. Anybody who wants to can download them and send their comments in. So I urge all of you to do exactly that. All you need to do is download the draft regs, which are up there, or if you go onto the ISA website, there's a little, like a ticker tape thing that goes along the top. Just click on it and it'll take you straight to the regs. And email your comments by 15 October 2019 to consultation@isa.org.jm. Please do this. And one reason I always say this in my talks to bodies like this is we don't get nearly enough serious input from engineers and technicians and scientists. We get a lot of environmental NGOs, but we don't get enough actual practical input from people who have looked at what it actually takes to do work at sea and how that needs to be translated into exploitation regulations. Because it's all very well to have those regulations there on paper sitting in Jamaica, but you're out there 5 days steamed from shore trying to figure out what this actually means with your collector that's not working very well all of a sudden. What do? This is why we need a lot more technical input. This is why I'm hoping that I can at least galvanize you all to do that. You've got about a month. And this is why, when you're looking at it again as a private contractor, this is why it's so incredibly expensive now. You have to factor all of this in. This is no longer a matter of metal prices and some good tech. This you have to spend an enormous amount of money. This is just in the exploration phase, even before you exploit. Look at all those data that you need to collect. And you need to collect them every single year, and you need to report to the report them to the ISA every single year. You need to do this for 15 years. You get exploration licenses for 15 years. So this is hugely expensive. The data required in more detail right here. And the interesting part about all of this, and if there is one take-home message I want to leave with you folks, is that in the last 6 years since the private sector came back on board, and it looked like they were getting really serious about mining more quickly, we have learned more about the deep sea in the last 5 years than we have in the previous 25. And that is something that is of incalculable value to mankind. Even if it all dries up and nothing goes anywhere, we will at least have had those data, that information, and I can only hope that we will not allow to have happen again what happened in the previous 25 years. We've ignored the deep sea because there wasn't any commercial interest, whereas now we need the oceans more than ever, we've noticed, in order to maintain the general health of our planet, that at least we will keep up with the research. Now, these are the sorts of research needs that we need, and this is the sort of research that all the contractors that are out there already doing the exploration and are trying to get some experimental data on. This is also a question that interests scientists and technologists and engineers to try to put together a unified picture to deal with not only the environmental consequences, but also to try to mitigate the environmental consequences as you mine, not to try to do it after. Because one thing I can tell you is that it is highly unlikely that any of this can be remedied afterwards. You want to try to make sure that you mitigate and reduce and prevent up front, not after the fact. So, here are my conclusions, and then you get your dessert. The ISA is a very, very open shop, much more open than most UN agencies. I do a lot of work with IMO. And they do great work. I've got an enormous amount of time for IMO, but gaining access to their discussions is not easy. It's easier to gain access to the ISA, in part because they've got a Common Heritage of Mankind mandate, but even so. It does require a certain amount of commitment. They meet in Jamaica twice a year now, in March and in July for 2 weeks each, and it's in Kingston, it's not Montego Bay, so you remain focused rather than go to the beach. But what we also need, as you can see here in the black, is you don't need to go to Jamaica for that, you just need to do a great deal of thinking, and whatever you think and whatever you want to propose, you can always send these ideas to the ISA at any time, or if you saw a contractor or a country you're interested in, you can communicate that to the countries in order for it to be communicated to the ISA. Everyone can be part of this conversation. Now, we can do it, and this is why we need to do it, because the Pacific Ocean is basically, just it alone is bigger than the rest of the land that we have. And I would like to thank you for your attention for this one, and don't applaud yet because you now get to see the movie. Now, I have to do something complicated here. And where is my lovely IT guy? Oh, hey, I think I can do it. I turn this off, there we go. And then I click on this. I was having a